So now you are getting an error at line number 36 where you are trying to create an object for class B, which is an abstract class. So now let me put this in comment. So then you will not get any error. Now you can run the program. So you're getting the output as C's implementation of call me. This is a concrete method. So you're getting the output when you call the call me method, it will display C's implementation of call me. And when you call me to will display this is a concrete method, right? If you try to create object for class A even, then also you'll get an error because both class A and class B are also abstract classes. So you cannot create objects for those abstract classes. Okay. So how to create an abstract class? Use the keyword abstract to qualify that class as abstract class, and the condition is that at least there must be one abstract method declared in that class, then only you can qualify that class as abstract. Okay. And along with the abstract methods, the abstract class can also have concrete methods like this, the call me to. And if you create an abstract class this way, you must definitely create a subclass for that abstract class, because we didn't completely implement this abstract method in the superclass. We must at least give its implementation in the subclass. And if that subclass is also unable to implement that abstract method, then we must qualify that subclass also as an abstract class, and at least create one more subclass for that subclass, and there you have to give the implementation for that abstract method of the super class, that is A. And even if C cannot implement that, then you need to create one more D and extend C and qualify that C also as a abstract class. So this can go at to any extent, any levels, but finally at one level you need to put an end to this extension and give a implementation for all the abstract methods, at least in that last level. So there is no meaning in defining more number of levels of inheritance classes, and finally giving a definition or implementation for the abstract methods at the top of hierarchy, but at the bottom of the hierarchy in the last class unnecessarily. So we should avoid such cases. What is the purpose of this abstract methods is, if you when they will be useful means, if you don't have exactly what to implement, if you don't know exactly what to implement in this method, that means what definition you want to give and what operations you want to perform in a method, then you can uh, make that method as an abstract method by simply giving a type signature for it, and then later, depending on the purpose, in one subclass you can give one kind of implementation, in another subclass you can give another kind of implementation. So you can change that implementation depending on the context, and depending upon the subclass where you are implementing, you can give different implementations as you wish. Instead of giving a one default implementation in the superclass and then overriding that method in subclasses, uh, we can go with this alternative, that is, don't give any implementation in the superclass and give only implementation in the subclasses wherever necessary, right? So if the subclass has if a class has two subclasses, say for example, that means you are implementing a hierarchical inheritance, then first subclass want to have one kind of implementation, that means it has to perform some different operation when compared with the second subclass, say C, which has to perform a different implementation or a different operation in it. Then what we can do is we can create a abstract method in their superclass, that is A, abstract method in superclass A, and then provide the implementation, concrete implementation for that abstract method based on uh, the requirement for class B. In subclass you can give a different implementation, and in class C which is also a subclass for A, there you can give a different implementation. So that is advantage of using abstract methods. So now that you understood how to create an abstract method, you have to use the method, you have to use the keyword abstract to qualify that method as an abstract method. And after you mention the type signature of the method, at the end you need to give a semicolon. There will not be any opening of brace and closing of brace and giving a body for it. So I hope you understood how to create an abstract method and how to create an abstract class. Only if a class has at least one abstract method declared, then only the class can be qualified as abstract class. And you cannot create an object for an abstract class. And the implementation for the abstract methods must be given in any of the subclasses of the class, abstract class. If you cannot do that, then you have to make that subclass also as an abstract class. So these are the conditions that you must follow when you use the concept of abstract classes and methods in your program, right? So any class that contains one or more abstract methods must also be declared as abstract. To declare a class abstract, you must simply use the abstract keyword in front of the class keyword at the beginning of the class declaration. So there can be no objects of an abstract class. That means you cannot create an object for an abstract class, because it is useless creating an object for that abstract class when it is incomplete, right? So coming to the fundamentals of abstract classes and methods, uh, what is an abstract class? Generally we have two types of, we can classify the methods of a class into two categories. One is concrete method, the other one is abstract method. Based on what, or from the which perspective? From the perspective of whether a method has a definition or implementation or body or not. So we can use these terms, definition, implementation and body, interchangeably. That means you can use, instead of body, you can use the term implementation, or you can also use the term definition. So depending on whether the method has a definition, implementation or body or not, we can classify them as concrete or abstract methods. If it has a definition, then we call it as a concrete method. If it does not have a definition, then we call it as a abstract method. So look at the syntax, how these abstract concrete methods will look like. They'll have a return type, method name, list of parameters in the parentheses, then they'll have an opening of brace and closing of brace, and within the braces you'll have the body of the method, where body of the method is nothing but it contains one or more statements. And coming to abstract methods,
Sir,
yeah,
so in hierarchical,
yeah,
superclass A, subclass B, and subclass C for A,
okay.
we can leave subclass B empty.
If you leave subclass B empty, then we need to create one more subclass for that class B, like we did in
Oh,
concrete.
okay,
You have to
okay,
take it
okay.
to the next level and make that B also as an abstract.
Uh,
Okay.
so in okay, sir, got it.
So abstract methods will have the syntax like this: a keyword abstract followed by the return type of the method, then the method name, and parameters list and their types within the parentheses. That's it, ending with a semicolon. There will not be any opening of brace, closing of brace, and body of the method. So this is the syntax for concrete methods and abstract methods. So till now we have been using only concrete methods in our programs, but today we are going to use abstract methods, as I told you earlier. So we are going to use abstract methods, right? So the keyword that must be used to qualify a method or a class as abstract is abstract. And these are the conditions you need to follow when creating abstract methods and classes. Okay, so let us see now one more example program for abstract methods. So this is another example. So we are creating an abstract class called figure. So because we have qualified this class as abstract, now this class must contain at least one abstract method. And I'm creating two instance variables, dim1 and dim2, which stands for dimension1 and dimension2. Both are of type double, and a constructor is defined for this class figure, which will initialize uh, dimension1 and dimension2 to a and b respectively, where a and b are parameters passed to the constructor. Both are of type double. And then now I'm creating the actual abstract method. So the method name is area, return type is double, and I qualified it as abstract. You can observe that there is no body for this method, it only has the type signature. Then I'm creating a rectangle which is a subclass for figure. So now, because I didn't qualify this rectangle as abstract, I must provide the definition or implementation for this double area abstract method of superclass figure in this class rectangle. Coming to class rectangle, we are creating a constructor for this one, and the constructor in turn will make a call to the constructor of superclass, that is figure. So why I am doing this here is because I cannot instantiate the superclass because it is a abstract class. Can I create an object for class figure? I cannot create, right? So that's why when you don't create an object for class figure, this constructor will never be executed. So if this is not executed, then this dimensions 1 and 2 will not be initialized with some value. So what we need to do, we need to create an object for subclass because it is not an abstract class. You can create an object for this subclass rectangle, and in the rectangle constructor we'll make a call to the figure constructor by using the super keyword and pass those two parameters that are received by this rectangle constructor as they are immediately to the immediate superclass figure. Then that constructor will be invoked, and dimension 1 and dimension 2 will be initialized with those two values a and b, because when you make a call to super using by passing a comma b, this a comma b will be copied into the constructor figures a and b parameters respectively, and those a and b will be initialized to dimension 1 and dimension 2 instance variables of the class figure, right? So now even though you didn't create an object for figure class, but because you're going to create an object for rectangle class, the instance variables dimension 1 and dimension 2 will be initialized through the subclass rectangle constructor, which it directly calls the superclass figure constructor and initialize the dimension 1 and dimension 2. Then the abstract method that we declared in the superclass figure must now be given implementation here in this subclass rectangle because we didn't qualify this class as abstract. If we don't give this one, then we need to make this class also abstract, that is rectangle also abstract, but I'm not doing that. I'm providing the implementation for the area abstract method in the superclass in subclass. So the implementation for area is you are displaying a message inside area for rectangle. And what is area of a rectangle? Dimension 1 into dimension 2. You can imagine or you can consider length as dimension 1 and breadth as dimension 2. So length into breadth is nothing but the formula for calculating the area of a rectangle. So I am returning the value of dimension 1 and dimension 2, right? Then I'm creating one more class called triangle, and this is also a subclass for the abstract class figure, and this also has a constructor triangle, and this also receives two parameters a b, and immediately it will pass those a b values to the superclass constructor, that is figure. So dimension 1 and dimension 2 now will be initialized as base and height of a triangle, right? And this triangle also defines that abstract method. Because it is a subclass, this must definitely implement that triangle method, abstract method. Always remember, irrespective of how many subclasses you create for an abstract class, all those subclasses must definitely implement that abstract method of the superclass. Because you created an implementation for that abstract method in one subclass, you cannot leave it in another subclass. All the subclasses must definitely do. It cannot be like one subclass giving implementation for abstract method and the remaining subclasses can leave it alone without giving implementation for that abstract method. It is wrong. All the methods, if there are two subclasses, then both the subclasses must give the implementation for that abstract method. If there are three, all the three must do. If there are four, all the four, like that. If there are n, all the n classes must give the implementation for that abstract method, because they are subclass for that abstract class. If they cannot do, then they also must be qualified as abstract, and you have to create subclass for those classes also to the next level, and at least there you have to give the implementation for that abstract method. It is like a family's wish not fulfilled in the first generation, then the second generation will try to fulfill it, and even if second generation cannot do that, then third generation will try to do that. So in that way, in general, how wishes will be fulfilled at different levels, different generations. Even abstract method concept also will be implemented in the same way in inheritance. So now that we have used a hierarchical inheritance here, we have a superclass called figure, and we have two subclasses for that figure, and the superclass figure is a abstract class. It has a abstract method called area method, and the two subclasses names are, one is rectangle, the other one is triangle, and both are defining the abstract method area in them, both triangle as well as rectangle. So in rectangle, we are displaying a message inside area for rectangle and returning the value uh, dimension 1 into dimension 2, whereas in triangle, displaying a message inside area for triangle and returning dimension 1 into dimension 2 divided by 2, because half into base into height is the formula for calculating the area of a triangle, right? So now that we have defined one abstract class and two subclasses for that abstract class, we are going to define another class called abstract areas, in which we are going to define the main method and create object for rectangle class and triangle class, and then make a call to those respective area methods to find the area of the rectangle as well as area of the triangle, right? So first what I am doing here is I am creating an object for rectangle, that object name is r, and I am passing 9 and 5 as variables, as parameters. So this 9 and 5 will be passed as parameter to the constructor of rectangle. So that is, a will have 9 and b will have 5. Then immediately you are making a call to the superclass constructor by passing the same 9 and 5 as parameters. Then this figure constructor will be invoked, and this double a and double b will receive the same 9 and 5, and then the 9 and 5 will be assigned to dimension 1 and dimension 2 respectively, right? And then the area method will be called, and area method, because it is rectangle is a subclass for figure, dimension 1 and dimension 2 also will be members of rectangle class. So we'll use the dimension 1 and dimension 2 and multiply them and return the result. to the place where we call this method, right? Then triangle object is also done in the same way. Triangle also has a constructor. This time for triangle constructor you are passing 10 and 8. The same 10 and 8 will be passed to figure constructor, and it will initialize dimension 1 and dimension 2 to 10 and 8, and that dimension 1 and dimension 2 also will be members of triangle class, because triangle is a subclass for figure, right? Now what I am doing is, instead of instantiating, I am just creating a reference variable. This statement is invalid, illegal, because you are completely instantiating the object by using the new keyword and making a call to the constructor of the figure. This will be called as instantiation of the class, but this will not be considered as instantiation. It is just creating a reference variable, because we didn't allocate memory using new operator, and we didn't call the constructor for the figure class here. So that's why this will be created. This is okay, no object is created, only reference variable is created. So for that reference variable you can assign a subclass object, right? We have done it yesterday in dynamic method dispatch, as well as creating a superclass variable and assigning a subclass reference to it. We have seen in previous programs. So as such, I am creating a reference variable for superclass and assigning it a subclass object R. Then in the system.out.println, I am displaying a message area is concatenated with the value returned by calling the area method. And look at how I am calling the area method by using figure reference, this object. This figure reference is an object of figure class, but I am assigning it object of subclass rectangle R, right? So I can do this and I can call the area method, because area now will be considered as an overridden method. It has its declaration in superclass and implementation in its subclass, so you will be allowed to call the overridden method. So as per the dynamic method dispatch concept, a superclass object can invoke overridden methods of superclass in the subclass, but other methods it cannot call. So now area is also an overridden method. The only difference is area does not have its own implementation in the superclass. It is only an abstract method, but it has a implementation in both the subclasses. So you can call that area method in this case also using that superclass reference variable figure reference, like this. Then after that, what I am doing is I am assigning triangle object T that we created earlier to the superclass reference variable figure reference. Now earlier it was referring to subclass rectangle object, now it is referring to subclass triangle object. So now if you make a call to the area method using this object, it will make a call to the triangles version of area method. So this is rectangles version of area method, and this is triangles version of area method. So if I call triangles rectangles version, it will return dimension 1 into dimension 2, that is 9 into 5, which is 45. And if I call triangles version of area method, it will return uh, dimension 1 into dimension 2 by 2, so that is 10 into 8 by 2, so 80 by 2 is 40. So area of rectangle will be displayed as 45 and area of triangle will be displayed as 40. So inside area for rectangle, This is displayed by area method of rectangle class, and then it will return rectangle area, that is 45. Then area method of triangle will display a message area for triangle, and it will return dimension 1 into dimension 2 by 2, that is 40, right? So this is how you need to use abstract methods and abstract classes in Java. So remember the points. What is that you learned newly here? In the previous program, what you learned here is any class that contains one or more abstract methods must also be declared as abstract. To declare a class abstract, you simply use the abstract keyword in front of the class keyword at the beginning of the class declaration. There can be no objects of an abstract class. That means an abstract class cannot be instantiated with the new operator. That means you cannot create an object for an abstract class because they will be useless even if you create also. You cannot declare abstract constructors, or you cannot create abstract static methods. So these abstract methods can be implemented only for uh, normal methods of a class. You cannot make static methods as abstract methods, or you cannot even make a constructor also an abstract constructor. Okay, that is the second point. Any subclass of an abstract class must either implement all these abstract methods in the superclass, or the subclass itself must be declared abstract. That means if the subclass does not give implementations of the superclass abstract method, then the subclass must also be declared as abstract method, and that subclass must be extended once again to create another subclass for that class. And there in that next level subclass, you need to give the implementation for the abstract method. So these are the points we understood from the first program. And coming to the second program, uh, what you understood, one more point we need to discuss in the first program here. So if you observe the first program, you can notice that no objects of class A are declared in the program. As mentioned, it is not possible to instantiate any abstract class. One other point is a class A implements a concrete method call me2. This is perfectly acceptable because abstract classes can include as much implementation as they see fit. Because you are creating a class as an abstract class, it doesn't mean that it cannot have concrete methods. So a class can have both concrete methods as well as abstract methods. If at least one of them is abstract, then we can qualify it as abstract class, right? Then coming to the second program, uh, even though abstract classes cannot be used to instantiate objects, they can be used to create object references because Java's approach to runtime polymorphism is implemented through the use of superclass references. We have discussed this in the previous programs yesterday in dynamic method dispatch, right? So thus it must be possible to create a reference to an abstract class so that it can be used to point to a subclass object. That is what we have done here in this program. We have created a reference variable for superclass, and then we have made it point to a subclass object R first, and then we made it point to another subclass object T. So this is acceptable when you are using abstract classes, but you cannot instantiate the object completely like this. So this is called as instantiation, and this is illegal, and this is simply creating a reference variable. It is not instantiation or object creation. So this is permitted, right? Hope you understood. Is that okay?
Yes, sir.
Okay.
Yeah, yes, sir. Can you hear me? Yeah.
Yeah, yeah. Okay. So your task is to practice some programs on these also. Abstract methods and classes concept. You try to write your own program. Don't use the same program that I used. You use it in different context for different computation. I've used it for areas of triangles and rectangles, right? So you can make something else.
Okay.